Hey everybody, I'm Chili. Welcome back to Beginner C++ Tutorial 20. It's time for another game project, but before we start, here are some dank meta tips. So let me tell you the preferred video consumption method for maximum success and pleasure. The first rule is you watch twice, then you code it yourself. And by code, I don't mean pausing every 20 seconds and looking at the screen, copying from the finished Git code, because you ain't gonna learn shit that way. So the first watch is the scouting mission. You get an idea for the whole thing. You see the big picture. If there's something you don't quite get, don't get hung up, don't stop the video. Often if you keep watching, it will become clear naturally later on as more info is presented. Now the second watch is more detailed. You're going to pay close attention and especially watch out for things you don't get. Maybe pause and rewind if something isn't 100% clear. Or you can also stop the video, maybe research on Google, take some notes, and make a list of stuff you're unclear on, and then you can ask for help on the Discord or in the forum. So after you've done the first and the second watch, then you're going to code it up for yourself. You're going to create a branch at the start tag and you're going to go nuts. You can go back to the video. You can peek at the Git code occasionally if you're drawing a total blank, but try to do so as little as possible. And remember that there's a forum and a Discord chat you can get help in. And don't think that, a few hours is the normal time required to finish something like this. Several days of work is normal as a beginner trying to hash this shit out for yourself. And let me tell you, that time is going to be 1,000 times more valuable than just monkey see doing the fucker up. Now here's some info specific to the videos of this game project tutorial. The whole thing ended up being quite long, so I split it up into 3 segments. The first 2 segments are nice and short, and they implement the basic gameplay elements. The third segment refines the ball rebounding behavior, the physics, so that it's much less wonky. And then after that, we're going to have a little bit of homework that shows a selection of some of the bell and whistle enhancements that you can add to this game. So what you're going to do is you're going to watch the first 2 episodes twice, and then you're going to attempt that stuff for yourself, but don't watch the third video. At the end of video 2, I will give you instructions on when you should proceed to video 3. So for your first coding session, I only want you to code the stuff for videos 1 and 2. But enough of this pep talk bullshit, let's get down to business. So the game we're making is, your classic brick breaker game. You got your bricks, you got your ball, you got your paddle, ball hits the bricks disappear, ball bounces off the paddle. The ball hits the bottom of the screen, it's game fucking over. Obviously, there are a bunch of, other mechanics that you can add to this thing. You got enemies, you got fucking power-ups and shit. But we're going to keep it simple here, just the basics. And we're also going to keep the physics of this, dirt simple. We're not looking for perfection here. We're going to start off, real buggy and broken, and we'll refine it to just, normal broken. Name of the game, by the way, is going to be Arpanauts, not to be confused with Arkanoid. Completely different game. Alright, so let's get started. What you're going to do is you're going to go on the wiki page, you're going to clone the motherfucking repo, and what you're going to get there is you're going to get the starting code, first of all, in this tag here. And the starting code is just a basic framework plus some shit that you should already know about. Vec2, we know that shit. Sprite codecs, frame timer, and there's also a couple of sounds that we're going to be adding later on. So, Arkanoid is all about breaking bricks. What are bricks? Well, they're just fucking rectangles, right? The bricks are going to collide with the ball, which is a circle, but we're going to treat the ball as a rectangle as well, because we don't want to deal with fucking messed up math bullshit. That's not the point of this video. So, the ball is going to be a rectangle, the bricks are going to be a rectangle, the paddle is going to be a rectangle. You know what I'm thinking? I'm thinking we probably want a class that can represent the idea of a rectangle, same as we did for a vector. So, we're going to add a header file, rectf.h, and in here we're going to create a class, rectf. Now, like I did for vec2, I'm also going to make the data members for rectf public. So we got 4 data members, left, right, top, bottom. They're all floats, and they represent, the sides of the rectangle. This shouldn't be anything new to you. We've been using this kind of concept for the Pooh game already. We just haven't made a class for it. Now, as for the data members, we need a basic constructor. like this that just takes left, right, top, bottom. Now, when we create our own constructor, that will disable the compiler from creating the default one. So we want to tell the compiler to make the default one as well. So doing rectf no parameters equals default will tell the compiler to generate the default constructor. Let's also add a couple of different constructors. We'll add one constructor that takes 2 vectors, one for the top left corner and one from the bottom right corner, and builds a rectangle from that. So we'll need to include vec2, and the constructor looks something like this. Notice we're passing in vectors by reference because we don't want to copy them, and constant reference because we're not going to be changing them. Man, let's just go buck wild on this bitch and add one more constructor that does top left plus the width and the height of the rectangle and generates it from that. Now, as for member functions besides constructors, we're going to want one that can check to see if 2 rectangles are overlapping, because that's what we're going to be using for our collision detection. So let's go bool is overlapping with, and then rectf other. Notice we're passing in by const reference, and our function is const because it's not going to change anything about the rectangle. It's only going to do a test. Now, if we hover over the green underlines, as you know, we can do create definition, and we'll create the definitions for all the functions. And when that's done, we just need to fill the fuckers out. And when those are all filled out, it'll look like this. I'm using the class initializer list to initialize the members here. And here is something that might be new, I can't remember. But what I'm doing here is in the initializer, I'm calling this constructor from inside this constructor. So this constructor is calling this constructor, and it's passing in the components of these input vectors. So left, right, top, bottom. Just using the .x and .y components to get the left, right, and top and bottom sides out of these vectors. And here in this constructor, I'm calling this constructor. So this constructor takes 2 vectors, right? This one takes 1 vector and a width and a height. So the top left is just the same, so I pass that in just as it is. But the bottom right is going to be the top left plus the width and the height. So I create a vec2 with the width and the height. I add that to the top left, and then I pass that in to this constructor. This constructor gets those components, passes it into this constructor. And it's all good. It's a very elegant way of implementing these different constructors based on each other. And here for our, overlapping test, this is just what you've been doing with the poo all along, so shouldn't be any news to you. Now that we've created this rectangle, I should test it before moving on, but I'm not gonna. I'm gonna cut that out because I don't want the video to be too goddamn long. But what I will do is I'll go into Team Explorer, Home, Changes, and I'm gonna commit this now as, rectf added, and we'll commit that bullshit. Yeah, whatever. Let's make sure it builds, actually. Even if we're not going to test it, we should at least try to build it and see we didn't have any syntax errors. And it does indeed build. Good. So next, let's start creating the entities in our game. We're going to have 3 entities, right? We're going to have bricks, we're going to have a ball, we're going to have a paddle. So let's start off by making some bricks, shall we? So we add a header to the project brick.h, and we declare the class brick. What data does it need? Well, it's going to need a rectangle to, determine the size of the brick and the position in the world. So that means we're going to have to include, rectf.h. Then we are going to need to put one in here. So rectf, and we'll just call it the rect. What else? Well, we're going to want color. So that means we include colors.h, and then we add color. And we're going to need one more variable, and that is to keep track of whether this brick has been destroyed or not. So we'll just do a bool, and we'll call it is. Now we'll just say destroyed. Destroyed. There we go. All right, so that's going to be the member variables for the brick. Now let's get into the functions. We're going to need a constructor for the brick. So our constructor is going to take the rectangle and the color, and let's just make destroyed default to false. Now we're also going to want a draw function for the brick, so let's go void draw, and oh yeah, we need to know about graphics in here if we're going to be doing that bullshit. So include, and let's see if I can not fuck this up. Graphics.h, good. Now we finish that up with a graphics parameter and make sure the function is constant because it doesn't change the brick in any way. And we implement the constructor like this, and for draw, we're going to be calling graphics.drawRect. But since we're going to be drawing a lot of rectangles, let's do something good. We'll go into graphics.h, and we'll add another version of drawRect. Void drawRect, and we'll do constant. We need this file to know about rectangles first of all. So we'll include rectf.h. And then down here, where is it? Draw constant rectf. No, that's not what I wanted. And we'll just call this one rect and color C. And this draw rect is going to be a wrapper for the other one. So we're just going to call the original draw rect. And we're going to go left top, right bottom, I guess. So rect.left. So here we've got a nice wrapper function that takes a rectangle and calls the int version. Very nice. Now if we go back to brick.cpp, we can call drawRect with a rectangle and color. And all should be well in the world. We build it and we get a whole shit ton of warnings because I didn't do my my casting bullshit in here, which is bad of me, bad chili. But if we add our typecasts in, we see that the compiler no longer complains, all is well with the world. So let's add some shit to our commits. So we got a bunch of changes here. Now I want to separate the commit of the change to graphics to the making of the brick. So what I'm going to do is I'm going to go into graphics, I'm going to go stage this. And when I stage this, then I can commit just this change here to this file. And I will enter a commit message, added draw rect, get rect mate, and we'll commit that. And then here, created breaky bullshit. Commit that. All right. Now what I want to do is just quickly test out the drawing and creation of our brick. So I'll include brick.h right here, and then I'll create a brick like this and draw it like that. And if we run this, it should make a brick on the screen. It's just a rectangle. No big deal. I'll just undo this test code here quickly, and let's move on. Time to create a ball. So we add ball.h, we declare the class, we include vec2 because we're going to need it, and for the data members for ball, we're going to have a vec2 for the position, a vec2 for its velocity, and we're going to create a constant for the radius of the ball, and that's going to be just 7 pixels. For the functions, we'll start off with a basic constructor here that sets the position and the velocity, and your basic draw function. Make sure to include graphics.h. Now the constructor here is self-explanatory, but for the draw, what we're going to do is in sprite codecs, we're going to use the draw ball function that draws a 14 by 14 sprite that is drawn from its center. So what we want to do is, first of all, we want to include the sprite codecs, and then in here we want to go, let me just get this one, sprite codecs, draw ball, and we pass in the center, which is just the position of the ball and the graphics, and that should be good. Do a quick test build. Now let's do a test of the drawing. So in game.cpp, we include ball.h. We create a ball passing in a vector position, and it doesn't matter what we pass in for the velocity because it's not being used yet. And then we just call b.draw. And it seems to be working fine. Nice yellow ball here. Maybe what were you expecting, like a poo? Don't be immature. So we'll undo that. Yeah. And let's commit our ball code. There we go. Alright, let's play with our balls a little here. We want our balls to move, our ball, so let's create an update function. We'll go void update, and this function is going to take a float dt because we need to know the time step, and note that it's not constant because we're going to be changing the object. And then we just add velocity times dt to the position. And Bob's your uncle. Now we want to test this bullshit, so let's go into game.h. Where is it? Where's my... We need to include frame timer and ball here. And then we need to add a frame timer and a ball object to our game class. Like so. Now we're going to go and we're going to... well, we have to initialize those guys in here. So frame timer is no problem, but we do need to initialize ball. So we'll give it a position and we will give it a velocity. something like this. In the update model, we want to get our delta time and then update our ball. And then in compose frame, we want to draw our ball. And it builds fine, and when we run it, ball is moving at a speed of, you know, whatever speed we gave it. 100 in the X and 100 in the Y. Okay, so let's celebrate with a commit. Something like this, and now we want our ball to bounce off of the walls. So, I mean, we know this from the Pooh game, but when an object with a velocity bounces off of a vertical or horizontal, got that wrong, a vertical or a horizontal plane, you're going to be reflecting one of the components. So if you bounce off something vertical, you're going to be reflecting the X, keeping the Y the same. And if you bounce off something that's horizontal, you're going to be flipping the Y, keeping the X the same. So in ball.h, let's add a function to do collision processing with the walls. And this one is going to return a bool so that we know if we have collided with a wall or not. That'll be useful. And just takes a rectf. So we're just going to represent our walls with rectf. We're not going to create a separate wall class. And we'll add a couple functions, rebound x and rebound y, and they will just, you know, do the x and y reflections. Now, for our do wall collision function here, we can't use our is overlapping rectangle method. So what we do is we're going to go if. So if the left side of the ball is outside of the left side of the wall. Now, first things first, our ball, if you remember, our ball doesn't have a rectangle. It only has a position and it has a radius. So we need to generate the bounding rectangle of the ball based on its position and its radius. What we're going to do is we're going to go into rectf. And what I would like to do is create, you know, rectf, and then just do something like this, constant. So I'd vec2, and that would be center. And then I would go half width and half height. And the idea for that is that now we can specify different rectangles based on their center and this dimension and this dimension here, like so. The problem is that we can't actually do this because look at this. This constructor and this constructor, they have the exact same signature, the same function name, and the same parameters, vec2, float, float. So we can't have nice things. What we can do, and what I often do instead of a constructor, is I would create a static function. That's a function that doesn't have to be called on any particular instance of the class. So we go static, and this will return a rectf. And I'll just call this function from center. And then we'll just paste these parameters in here. And now we've got it's almost like a constructor. You might call this a factory function because it creates objects. And in the factory function here, first I'll create a vector called half, which is just the half width and the half height. And then I'll return a rectf constructed by the center minus half and the center plus half. So that's center minus half would give us this point, center plus half would give us this point, construct rectangle from two vectors. Now let's add a member function to ball, and this one is going to return rectf, and it's going to just do get, it's going to be called get rect mate, and it's constant because it's not changing anything, it's just getting the rectangle of this ball. And then in do wall collision we go const rect f, I'll just call this one rect is equal to get rect mate, and now we'll just do our test. So if rect dot left is less than, not vols, walls dot left. So on this side, we're colliding with the left side of the wall boundaries. And then we call rebound x, right? And then we return, no, we don't return true. So let's create a boolean, bool collided, and we'll set that initially to false. And if we ever collide in any of these tests, we will set collided equal to true. All right, so first we check the left, then we check the right. Can't be simultaneously colliding with the left and the right, so we do else if rect.right is greater than walls.right. Again, we rebound x, collided is equal to true. Now we just got to do the same idea, but for the top and the bottom. So we do the same tests for the top and the bottom, and we rebound y if they pass the test or fail, whatever you want to call it. Then for our return, we just return collided. And that will return a value depending on whether or not a collision had occurred. And there you go, you got your do while collision, your rebound x and rebound y, pretty goddamn simple. Velocity.x equal to negative velocity x, velocity y is equal to negative velocity y. And get rect is going to return rect f from center position and radius for the half width and the half height. Now in game.h, let's add a rectangle to represent the walls. Like this, in game.cpp, we're going to initialize that rectangle. We'll set the walls to just be the visible region on the screen. And now we've got to go ball dot do wall collision walls. If we build and run, we get this. Could have made the ball go a little faster, but it's okay. And we don't get any crashes when we hit the wall, so that means we're not going, oh shit. We do get a crash when we go up here, so I missed one kind of super important thing, and that is when you are outside of the screen, you need to reset the position of the ball back to just be touching the side of the screen, right? You got to adjust the position of the ball so it's no longer outside of the screen. So what we do is we go, so the position dot x of the ball, and so here's the deal. The left side of the ball is less than the left side of the wall. So what we want to do is we want to move the ball to the right by this distance here, which is going to be the ball's left, the wall's left minus the ball's left. And we add that to the ball's position to move the ball from here to here, which will put its edge right on here. It'll be like this. So what we got to do is we go ball position.x plus an equal walls.left minus rect.left, which is the rectangle of the ball. And this adjustment will move the ball so that it is no longer outside of the window. And then we reflect the velocity and we do our bullshit. Let's do the same for these other fuckers. So if we're colliding on the right, we want to subtract from the position this distance here, which is going to be our rectangle dot right minus our wall dot right. So here we do pause.x minus an equal rect.right minus walls.right. And the same thing for the y. And that looks like this. Let's go in quickly into game.cpp. Where is my game? And we're going to change the velocity to 300 because I don't want to wait for my life to be over. And run this fucker. Fucking run. There we go. Good. Thank you, come again. Awesome. All right. Ball is rebounding off the walls. Total success. Mission accomplished. So now rectf, I want to put this in as a separate commit. So rectum damn near killed them for that. And my balls are bouncing off the walls. See, that rhymes. You get bonus points for commits if they rhyme. And now what do I want to do? Well, let's add a little sound, shall we? I think this is actually the first tutorial where I'm doing sound in the tutorial, but I'll put a link on the wiki page to there's a guide on how to use the sound module of the framework. So if you're not familiar with this or you want some more detail, look on the wiki page, click on the link to the sound module tutorial. So I've got some sounds in here in the folder sounds. And there's arc brick and arc pad. We don't have the pad yet, but we'll use the arc pad sound for bouncing off the walls for the moment. So what we want to do is we'll go into game.h. We're going to include sound.h. And what we're going to do is we're going to add a sound. And I'm going to call this one sound pad, even though we're going to use it for the wall. It is intended for the pad, and ultimately it will be used on the pad. Now, we need to initialize that fucker. So, sound pad, and this fucker is going to there's a whole bunch of different ways you can initialize this fuck. But the easiest way is just pass in a goddamn string. So, we haven't done strings yet, but it's super simple. Just put an L in front of these double quotes and you're good to go. Now, it's going to be in a folder, sound, and then we do double backslash. Trust me, you need double backslash, not single backslash, no good. Sound, and then it's going to be arcpad.wave. And this will load this wave file into the sound object. Then, do while collision returns a bool, so we go if. Now we got to put this inside of the if thing. I don't know what you call the thing inside the round brackets, like technically. I guess it's if statement, but that's the whole thing, right? Including the if. What's just the if condition? The if predicate? I don't know what you call it. But anyway, so if ball.do while collision, then we want to go sound pad dot play, and it's that goddamn easy to play sound with the fucking chili bullshit. So we do the thing, we test the thing, and exception caught, fail bit. Okay, this means file exception. This means it was not able to load. So I fucked up the name, I guess. Sound backslash arcpad.wave. All right, let's look here. It sounds though. It sounds though. You got to get that. Got to get that plural in there, chili. All right, let's try it. All right, we're running. We got sound. I don't know if you can hear this, but it's definitely sounds like stuff. Good. Now let's go. Sound test. Walls. We'll do that. Good. And that's going to be the end of part 1. I hope you are enjoying the tutorial so far. If you are, please click the like button. It helps a lot. You can take a quick Waz break, maybe fill up on some Mountain Dew and Doritos, and I will see you soon in part 2.